Okay, now we're going to have a look at group 7 elements, and these are over on the right hand side of the periodic table, not quite at the end because you've got group 0 there, but the next column in. Now group 7 are known as the halogens, which means salt formers because they react with metals to make salts. Now because they're in group 7, it means that they have 7 electrons in their outer shell. Fluorine, chlorine, bromine, iodine are all group 7 elements. Chlorine is actually used to sterilise tap water and swimming pool water, and it kills harmful bacteria, making the water safe to drink or to swim in. Chlorine is also used to make pesticides and plastics such as PVC, polyvinyl chloride. Iodine is used as an antiseptic to sterilise wounds. Now, a common exam question you may be asked is what do these chemicals look like? So chlorine is a green gas, bromine is an orange liquid, and iodine is a grey solid. So if we had a look then at how these chemicals actually react, because the thing that group 7 love is they love to react with group 1, and if you remember that would be an ionic bond. Now if you look here at this table you will see the reactions that you get. So if you had lithium and you joined it together with chlorine, it would become lithium chloride. Remember, it becomes an ide when it joins with something. So you'll see there, bromines become bromides and iodines become iodides. You must get that right, because if you don't, the examiner will mark you down. Well, just won't give you any marks because it's technically wrong if you put lithium chlorine. But you can see it's fairly straightforward. You know, sodium's Na, chlorine is Cl. Put the two together, you've got NaCl. Please be very careful that if you have two letters that represent a symbol, that you use a capital letter first and then a lowercase letter second. Okay, so be very careful then. So if we had a look then at a reaction, you could see that sodium would react with chlorine, make sodium chloride, NaCl. Just a little pointer here, group 7, they don't like going around on their own, they're a bit shy, so they always like to go around together in pairs. So we call them diatomic, di meaning two, atomic means in atoms. So fluorine is F2, chlorine is Cl2. So if you're asked to do a symbol equation with sodium and chlorine, for instance, don't forget that chlorine has to have a little number 2 by the side. Any group 7 element has to have a little number 2. And then if you're balancing the equation, you'll see you need to add a 2 in front of the sodium and in front of the products at the end. Okay, now when we talk about group 7, and we can look at these things called displacement reactions. Group 7 elements can react with the metal halides in solution. For example, chlorine reacts with sodium bromide solution. So if you had chlorine and you put it into a test tube with some sodium bromide, then what would happen is the chlorine is a bigger bully than the bromide, and it would push the bromide off to become bromine, and it would take its place, so it becomes sodium chloride. It's displaced the chemical, and that's because whereas in group 1 it was more reactive as you went down the group, with group 7 it's more reactive as you go up the group from the bottom. Okay, so the one at the top, fluorine, is the most reactive, and then chlorine, and then bromine and iodine. So it's all about whoever is the most reactive will push the other one out the way. Please be careful, because sometimes I'll put a question in there where there is no reaction because it's not as reactive. So here's some examples. So if you had potassium chloride and you put bromine into the reaction, nothing would happen because chloride is more reactive than bromine, and the same for iodine. However, if you had potassium iodide, now the iodide or the iodine is quite near the bottom of the reactivity chain. If you had that and you put chlorine in, the chlorine would push the iodide out of the way, so it would become iodine again because it's on its own, and it would become potassium chloride. Okay, so just remember, the further up the group 7, the more reactive it is. So if we have a look at some of the properties then, fluorine is the first element, it's the most reactive element in the group, and it will displace all the other halogens from an aqueous solution of their halides. Astatine is the 5th element, semi-metallic, it's radioactive, only very small amounts of it exist naturally, and it's the least reactive out of the lot. As you go down group 7, the melting points and boiling points increase. As you go down group 7, the density increases. And the last thing we're going to look at is trends. Okay, halogens have similar properties because when they react, they all gain 1 electron to form a negative ion because they've gained more in negativity with a stable electronic structure. They're happy now because before they react, they've got 7 electrons in the outer shell, and if they gain 1, they fill it up to 8 and they are quite happy. Fluorines are most reactive as it's the easier to gain the extra electron because the energy level or shell that the electron is entering is nearer to the nucleus. Remember we said about the shielding for group 1 was because of the outer shells moving further away from the nucleus, and that's why they became more reactive. As you go down the group, they become less reactive as the electron will be entering a shell that is further away, so there will be less of a pull from the nucleus, and also there are more electrons between the nucleus and the electron entering. Okay. The other thing you may be asked is to talk about thermal decomposition, and if that's the case, just think about thermal means heat, decomposition means breaking down using heat. Okay.